Hello guys, welcome to another video. In this video, I'm going to be showing you how to build a facial expression classification model without writing any code. Don't worry, if you think this is not possible, it is possible. To do that, I'll just give you a backstory. So recently, I've just been hearing about this no-code movement. Apparently, it's been around for a while. And I think this might be game changing. Personally, I write code on a day-to-day basis. My work is basically writing Python code and building machine learning and AI models for clients and helping them to solve their problem. And the models might be different, but the process is usually almost the same. So it's possible to automate some parts of the work. And so when I hear of this no code idea, I was really curious. So I'm here just to test out this idea. You should understand that for this to be possible, there is a back end where a lot of developers have worked tirelessly to write the code for you. So you are just using the code that someone else has written, and they have made it really useful to many people. So I went online to check out like many ideas. And today I'm just going to be testing out one of them that I think it's really simple. Anybody can use. As long as you have a simple knowledge of machine learning, you can basically use this tool to build any classification model that you like. I'm just going to show you right now. However, I want to mention some other platforms that might be useful, but I think that this one I'm showing you right now is just straight to the point. Anybody can use this one. But there are so many others like Create ML from Apple. You need to use Xcode in this case. So there's a barrier there. And there is a Share Insight on AWS, that's Amazon service. And I think the Amazon's web service also have their own interface that allows you to build with no code, with really not writing much code. And there is What If too. There is the Google AI platform. Google is also having this idea also of trying to allow developers not to write much code and just use their services. There is Data Robot, there is ML Kit from Google, there is Big ML, and there is Azure Automated Machine Learning from Microsoft. So the one I'm going to show you today is called a Teachable Machine. I think it's built on top of Google's API. Right now, they can do images, sounds, and poses. And as a matter of fact, images is maybe more than 60% of most of the machine learning solutions that people are working on right. So being able to classify images is a very big thing. And I'm going to show you an example. So, and you can see this, you can see very simple interface. So how do you use it? You gather images, train the image, and export. Basically 3 steps. And it's very easy. So you can see this is how to use it. And these are some examples. Today, what I'm going to try to do is to build a facial expression recognition model. And I'm just going to try to test this no-code solution and the platform out and probably give you the pros and the cons, because personally, I know the code path, how to do this with code. It's basically what I do every day, but it's amazing to see this kind of solution also online. So we're going to test this out right now. So I'm just going to get started. And it seems that you don't have to register. You can just get started. You don't need to submit any of your data. So this is really good, right? And so we're going to try an image project because we're doing a face expression recognition, right? So yeah, it's going to be an image project. So you can see this. This is really cool. Just the 3 stages that they talked about here. If you don't know anything about machine learning, just consider this as the simplest and the down-to-earth way of getting right into machine learning. So you have these classes here. So classification is basically trying to determine if the content of an image belongs to one category or the other. In this case, we have a facial expression problem that we want to work on. And so we want to determine if the facial expression of the person at a particular time is either of 5. So it's going to be like smile, like frown, straight face, peace, okay. So I'm just going to quickly build that up right now. So let's first try like 2 classes. So just to make it very simple. So I'm going to try to recognize smile. So let's name this smile, and let's name this frown. Yeah. So those are the 2 classes that we want to start with. So and you can see here we can add images If you have your own images, you can just upload here, but I'm not doing that. I just want to try this out, directly. So I'm going to use my webcam here to collect some images. So let's try that. So I'm going to okay, it's asking me to allow my webcam. So I'm going to allow my webcam so you can see me right now. So I'm going to look at the webcam. So you can see, don't mind the background there, it's really messy. But anyway, you can see my face in the webcam. It's really, it's almost like real time, right? So now I need to collect data. And one thing in machine learning is that you want to have a variety of data as much as possible. So I'm going to try and smile and turn my face left, right, and maybe up and down like this so that I can get like as much views of my face as possible. So I'm gonna do that. Hold to record. Smile. Done. Then face up. Then down. Okay, we have about 367 images. This is good. So well, we have a problem, which is not a problem right now, but it will be a problem in the future, which is the number of samples of images. It's quite small, but in the real application, you want to have as many images as possible. So I'm going to try to frown. I'm not a good frowner, frowner, so to say, but I'm going to try that now. So let's see. Okay. So one thing you realize that this is quite easy because there are features that already shows these images are different. Like you can see here, in this one, I'm smiling and my teeth are really showing. And here I am just like boning my face and my teeth is not showing. So this is two very big features. So I'm going to try and train the model. I can see here that I can just press the train model, but not to take too much time. Let us try to reduce this number of epochs. So if you don't know what epochs mean, is basically how many times you want to pass this samples into the model. Of course, we cannot see the model right now. We don't know exactly what kind of model they're using in this website, but you want to pass these images as many times as possible into the model and allow the model to learn the difference between the two images as many times as possible. So one epoch is when you pass all the images. And so you want to do that many times over. And the batch size is how many of the images you want to pass into the model per iteration. The learning rate is how much of the model do you want to correct at every iteration or at every batch. If you're building a custom model, these are things we call hyperparameters that you have to change and find the best combination of these three. So I think I would want to go with something very small. So maybe I'll just go with 15. Maybe for a more difficult task, we can choose something very high. But I think this task is very simple. So I'm going to use 15 and I'm going to leave the rest like that. So I'm going to train the model. So preparing training data, you can see it there. And let's see how long it's going to take okay. Web page is slowing down your browser. What would you like to do? Yeah, I like to wait. Let's see what happens. Okay, still waiting. Oh, now it started training. So it tells you do not switch tabs. You must leave this tab open to train your model. Okay, I got it. And you see it's trading 10, 11. I think I want to, okay, let's see some other things here. You can see under the hood. Okay, I think this under the hood is showing you trade accuracy. So yeah, this is more like some reporting here. Don't mind this for now. I just want to explain what is happening here. At every epoch, it tries to see how much accurate the model is, right? So it tells you how good. So basically, you want the accuracy to be high when you're training, and you want the loss to be low, really. So let's close this for now. And so you can see something going here. So it's already doing an inferencing. Inferencing is the application of the model on a real scene. So you see that it's like confused between smile and frown, and I think it's because of my teeth. So if I show my teeth right now, so let's see if it can recognize smile. You see? So it recognized that I'm smiling with 100% accuracy, and frown. Yeah, it's pretty good. So, but because we have only two classes here, so it's pretty confused between these two. It's normal for this kind of thing to happen. So, you can see, so it's pretty good. And within how many minutes? Less than 10 minutes now, I think, been able to train the classifier. So now let's add more classes. In practice, if you already trained for two or some set of classes, and you now want to add more classes into the model, you would have to write some extra code to accommodate. It's not going to be significant anyway, but you have to kind of do the process again. And imagine this case, we can just add a class by clicking here and clicking here and clicking here. So the no code idea is basically trying to, so let me stop this one. I mean, just to make things easy for you so that you don't have to write the code and you just do click and drag and drop in most cases. So now let's add three more classes. So expression. So I'm going to add a class for straight face. This is just to make add a little confusion to the model and see if it can actually recognize between straight face and a frowning face. So I'm going to add okay, and I'm going to add peace because I'm in Japan. So peace is a very popular expression here. So let's collect some data for that. To record straight face, no smile, no frown, just me straight face. So let's do okay. Also okay the same way. So same way. Okay. Just make it a little more variety there. All right. So we have okay signs. Just trying to make this balanced a little bit. So you can see that I'm using two cameras here. So there's a shift in the color of the cameras are different, but that should not be a problem. So the peace sign is like this, right? So let's do that peace sign. I'm gonna do a peace sign. Okay, so this is good. In reality, I mean, you're going to have a lot of image sources, so the color should not be a big deal. It would affect your model, but it should not be a big deal. So having two different image sources here is not uncommon. So let's try and train this time. Now let's use, oh, you can see it gives us some explanations here. It's good. So batch size, yeah. So I'm gonna maybe use 30 epochs just to increase that. And let's see how long it's gonna. I'm gonna also try to look under the hood this time, see how it's training, so you can see like the progress here. And let's train the model. Still have to wait. Oh, started training now. So let's see, and let's not show this again. And yeah. This time, let's see how long it's going to take to train. And you can see the progress here. Basically, it seems that the model that you're using on the background is very, very powerful. So from the second to the third epoch, the accuracy is already good. So I would imagine that they're using like this, very powerful models like ResNet or maybe from Google, like the inception models, the exception models. There are so many models that Google came up with that are very, very, very powerful. And they are going to be pre-trained models, I want to imagine also that, so that you don't have to train from scratch. So this is more like a transfer learning stage, basically. So the models are already being trained. So we are just fine-tuning the model on these 5 classes, which makes it very, very fast. And as a matter of fact, is that if I'm running this on my system, it's going to be much slower than this. So you can imagine they have a huge compute on the back end that is really working to make this really fast this way. So yeah, it took less than 2 minutes to train that, which is very impressive, I have to say. So let's check out some other things here. You can see they also try to explain some things to you, so that if you don't have any idea, at least you can see, you can have good overview of what is happening. So training samples, test samples. They're using 85% of the samples here as a training sample, and 15 as a test sample, which is good. So let's close this. And this is some kind of report. So accuracy per class, let's check that. This is something you have to do also. So you can see it's pretty much accurate for all the classes, which is impressive also. Calculate confusion matrix. Confusion matrix is more like trying to see which classes are confusing. So since you have 100% accuracy for all the classes, this is pretty much what you expect in the confusion matrix. Yeah, so let's see, let's check this out. I'm gonna use the other webcam now. Let's just, okay, so smile, yeah, frown. Now straight face. I think there's a problem because the image sources are different. So what if I switch webcam to one? So you can, it's very interesting, you see. Because I use two different cameras for the different classes, it kind of assumes that these different cameras means different classes. Even if I smile using this camera, it doesn't recognize that smile because it's a different camera. Basically my fault because I should have mixed it up. So this is what I'm going to do. I'm going to collect another set of images using different cameras for this and different cameras for this. So we're going to try and train that again. So let's try it. So yeah, it's off. Yeah, got it. Now we have like both image sources from here. It should not be confusing anymore. Now let's do for frown. My frown face is really weird. Okay, let's try for this. So in this case, I'm going to switch the webcam back so that we have a mixture of both in all the classes. So yeah, this one here. This is your face. Okay, that's good. So let's do that for okay. Switch. Okay, okay. Okay, not bad. All right, so for this, integrated webcam. Okay, all right, so now let's see moment of truth here. So again, we train for 30 epochs. Now start training. Jeez. All right, let's see on the wood here. Still pretty much the same outcome. That took about 3 minutes to train, and it's pretty much the same trend. After 10, up to 15 epochs is already good. So close this one. Let's see accuracy per class if it's still the same. Well, it looks like it's the same so far. Okay, so I'm gonna close that, and now we're gonna test. Now I'm gonna test on both, so you can see like it's given. Yeah, I mean that's good, right? So it's giving outputs on all the classes. So first, let's test for this. The camera below here. Smile, good. Frown. See, this is a problem here, so it cannot recognize between frown and straight. I know this is going to be a problem, but it's normal, so it's kind of confused. So straight face, I think straight face looks easy. Okay. See that? Pretty good. Peace. Okay, and peace is kind of confusing here. And so this is one thing. I think the model is overfitted on the training set. So this is kind of things that you deal with as a machine learning engineer. You have to deal with overfitting. So it's basically memorizes all the images that I gave to it. And because I'm imagining, because it's a large model, so it's possible for it to actually memorize this. So if I was to give it one of these images back as a test, it's gonna get it right. But this is, I mean, this is a real application now. This is like inference application, so you can see that it's really confused. For OK and peace, it's not that bad. You see, it's not that bad. So let me switch to the other camera. Yeah, smile. This other camera is okay. So because I have to look straight in camera, but I did this right. Not bad. Frown. Yeah, for frown and straight face, still bad. I think he's pretty much convinced that it's a straight face than frown, so that's a big problem. Yeah, for OK, I expect that to be correct. And for peace, yeah, peace is kind of tricky for the model. And even though we did this, still not very. So it's get it right here, but yeah. So this is pretty much something that we have to deal with, and but I'm really impressed with the interface because it's it's really easy to use. I'm just like on this interface throughout, and it's basically drag and drop and using my webcam. And check this out, I can export the model. So it tells me here that I can use it with TensorFlow, which is good. Normal TensorFlow or Keras, which is also very good, and TensorFlow Lite. So I imagine that at some point you will still have to write some code. I mean, if you want to apply this in a real setting, maybe in an app or somewhere you want to use it, so you have to write some code to kind of put it together. But let me know if you want to see me like do a full application with this, and I would really be interested to do it without writing any code at all. Please just write it in the comments if you want to see something like that. And if you also want to see me like compare this with if I write my own code and try to do the same thing, if you want to see that, please also let me know in the comments if you want to see that. So that's it. I mean, we've been able to pretty much train expression. Smile, good. Frown, not good. Straight face, nice. Okay, get it right. Peace, tricky. Okay, so which is like 50% accurate, I think. So thank you for watching and see you in the next one.